Question 6 about a heating unit on the rear window of a car. And the key information: heat is generated at a rate of 45 watts. Well, the rate at which you generate energy, another word for that is the power. And of course, the fact that it gives the units of watts tells us that's the power. And we've got to calculate the current through the circuit, and it tells us it's going to be approximately 4 amps. So let's have a look. The power's 45 watts. It's a 12 volt battery, so P equals V times I. So the current equals P divided by V, which is 45 divided by 12, and 45 divided by 12, I'm not going to do the calculator because I know what the answer was because I did it yesterday. It's 3.75 amps, which we should write maybe as 3.8 amps. 3.8 amps. And it said show that it's approximately 4 amps. Well, if we've shown it's 3.8, then we've shown it's approximately 4. Next bit of the question: use the value you calculate. So it doesn't want you to use 4, it wants you to use 3.8 to calculate the total resistance of the unit. So if we know the current, and we know it was a 12 volt battery, the resistance R equals V over I, which is equal to 12 divided by 3.8. 12 divided by 3.8 equals 3.16, let's put 3.2 ohms. Next bit, show that the resistance of each strip is about 16 ohms. Now there's various ways of doing it. Some people sort of started by saying you had 5 resistors in parallel that were each 16 ohms, and it showed that gave an answer of 3.2. You shouldn't really do that. When a question says show that the answer is something, it really means work it out and get the answer and then spot that it's 16. So this is the way I'd do it. Let's say that we don't know what the resistance of each strip is. We call it R, but there's 5 of them. So 1 over R plus 1 over R plus 1 over R plus 1 over R plus 1 over R will equal 1 over the total, and the total is 3.2. So what we've got 5, 1 over R, so it's 5 over R equals 1 over 3.2. If we arrange that equation by bringing the 3.2 up, so you've got 5 times 3.2 divided by R equals 1, so 5 times 3.2 equals R. R equals 5 times 3.2 equals 16 ohms. So we've shown that each strip's got to be 16 ohms. That's what we're supposed to do. Part B. I had all sorts of nightmares with people doing this. I think people got so used to doing examples that we had to get the diameter and find the area that you couldn't actually do something. It was easier. Each strip is 2.5 millimeters wide and 0.8 millimeters long. It determines the thickness, and it tells you the resistivity. So the equation on your data sheet: resistivity equals RA over L. We're trying to find the thickness of each strip. Well, that's connected to the area. So rearrange the formula. Area equals rho L over R. 5.0 times 10 to the minus 5 times length is 0.80 divided by the resistance, which was, for each strip, it's 16. Short of space here. That was a bit bad planning, but I overwrote the question. Could do it in my head, but I bet you wouldn't. I bet you'd do the calculator. So let's do it on the calculator. 5 times 10 to the minus 5 times 0.8 divided by 16 equals 2.5 times 10 to the minus 6. 10 to the minus 6, and that's the area, so it's metres squared. But we know that for a strip, the cross section is rectangular. So the area is equal to the width times the thickness, and we're trying to find the thickness. I'm doing just what I tell students off for, writing underneath, but there wasn't enough space. So the thickness is equal to area divided by width. A lot of people got that right. Where they went wrong, 2.5 times 10 to the minus 6 is the area. The width is 2.5 millimetres. And what a lot of people forgot is that the equation's got to work in metres, so it's 2.5 millimetres means times 10 to the minus 3 metres. 2.5 times 10 to the minus 6 divided by 2.5 times 10 to the minus 3. Could do it on the calculator, but I'm not going to do. The 2.5's cancel. 10 to the minus 3 divided, 10 to the minus 6 divided by 10 to the minus 3 is 10 to the minus 3. So it's 1 times 10 to the minus 3 metres. In other words, it's a millimetre. Right, the last part of the exam. The rear window heater sometimes turned off to save the battery. If the charge stored in a fully charged battery is that much, how many hours would it take to fully drain the battery with the heater? So, charge, time, what connects charge and time? Current connects charge and time. Current equals charge being moved, delta Q, divided by T, and we're trying to find delta T. So delta T, how long does it take to discharge the battery, would equal delta Q divided by I, and we know how many coulombs you've got, 1.44 times 10 to the 5, that's the charge. What's the current? Well, I've forgotten, but we must have worked it out earlier. Yep. Earlier we worked out that the total current in the circuit is 3.8 amps. So divide that by 3.8, 1.44 times 10 to the 5 divided by 3.8 comes out to 37,895 seconds. I'm not going to put all those figures down. I'm going to put 3.79. 1, 2, 3, 4, 3.79 times 10 to the 4 seconds, but it asks for in hours. So if I divide that by 60, it gives the number of minutes, and divide by 60 again, gives the number of hours, 10.5 hours. You might get a slightly different answer depending on whether you rounded the current or not. So there it is.